Hello, good morning, students. Today I am going to start the second part of the unit, semester 3, which is our atmospheric reactions, and in this we will going to study first of all autocatalysis या autocatalyzed reactions. The process in which one of the product of reaction acts as the catalyst in the same or coupled reaction is called as autocatalysis reaction. Auto means by itself. ठीक है, जो रिएक्शन में रिएक्टेंट है या जो प्रोडक्ट है या जो इंटरमीडिएट है, अगर वो खुद कैटलिस्ट का काम करने लगे उस रिएक्शन के लिए एक बार बनने के बाद, तो वो परिस्थिति ऑटोकैटालिसिस कहलाती है. फॉर एग्जाम्पल, हाइड्रोलिसिस ऑफ एस्टर is autocatalyzed by the acid, which is the product of the reaction. For example, if we take RCOO CH3, ठीक है, RCOOR CH3, when this ester is catalyzed by water in presence of acid, it forms RCOOH plus CH3OH. In this reaction, the acid which is formed is itself react as catalyst. Similarly, we can take RCOOR dash. Here R is alkyl group and R dash is some different alkyl group. They, when hydrolyzed by water, they form RCOOH and R dash OH. Second example of catalysis is during the titration of warm solution of oxalic acid with KMNO solution. The reaction is required induced initial some time, but after that initial time reaction, the rate of reaction takes place at very high speed. That is, here Mn plus 2 ions which are formed in this reaction act as catalyst here. Increase the rate of reaction. Reaction is 5 molecules of oxalic acid या oxalate ions combines with 2 molecules of MnO4 ions or MnO4 molecules or MnO4 ions in presence of 16 hydrogen ions, and they form 2 Mn ions plus 8 water molecules plus 10 CO2. This is a question which is asked regularly, why we need to warm oxalic acid before titration. Because at low temperature reaction does not occur. It requires initial induced time. So first we take oxalic acid in a conical flask and we heat it up to where it is lukewarm. In lukewarm oxalic acid, when we add KMNO from the burette, the color disappears. In cold, this reaction takes time. In some hot oxalic acid, reaction is fast. You add KMNO4, the color disappears. You add on and it disappears. And at end point, only there is no indicator in this titration. There is only a pink color of KMNO4. This reaction is known as autocatalyzed reaction. It does not react as this does not react at low temperature, but at some high temperature it reacts very fast. And Mn4 ions which were once formed in case of lukewarm oxalic acid, they act as self-catalysis, autocatalyze this reaction. So Mn ions are autocatalyzed, but this reaction does not take place at low temperature. Example 3. In the reaction of nitric acid with copper, ठीक है, with copper, NO2 ions are formed in reaction and they act as catalyst. Reaction is 3 copper atoms combine with 8 nitric acids to form 3 copper nitrate molecules, 4 water molecules and 2 NO. These nitric oxide molecules, 2 molecules combines with oxygen in water in aqueous medium and form 2NO minus, so they act as autocatalyst. Now here comes the mathematical expression of autocatalytic reactions. CH3COC2H5. This is an ester. It when hydrolyzed with water, it forms CH3COOH and C2H5OH. This is acidic medium. Initial concentration of ester is A, and initial concentration of acid is B. Okay, after some time T, some of the ester is hydrolyzed and is converted into acid and alcohol. Okay, so if X is the amount of ester which is hydrolyzed, now the remaining amount of ester which is present is A minus X. Similarly, the acid which is formed is B plus X. Initially it is B and now X are added to it. And initially ester concentration is A and X is consumed from it. According to the law of mass action, d by dt of X is equal to K into rate constant K, and is A into concentration of A minus X and to B plus X, concentration of B plus X. Okay, rate depends on A and B both. Or we can say dx upon A minus X into B minus X is equal to K into dt is equal to K into dt. राइट हैंड साइड पर K से dt को लेफ्ट हैंड साइड के dt से मल्टीप्लाई कर दो एंड dx अपॉन A माइनस एक्स प्लस बी आ जाएगा. ऑन सेपरेटिंग वेरिएबल्स, इनको अलग अलग करने पर क्या होगा, 1 अपॉन A प्लस बी. ठीक है, ये दिस इज कॉमन for both the category of reactants. It comes out and we have 1 upon A minus X plus 1 upon B minus X into bracket close dx is equal to K dt. This is important, K dt. Now on integration, this whole equation B, we get 1 upon A plus B into ln B plus X minus ln A minus X. And this is equal to Kt plus C. C is a integration constant. C क्या है? C is integration constant. If we plot a graph between concentration of B and time, then we get a graph like which is shown in the figure. Here, this is not starting from the zero concentration. Zero concentration is zero time. It is starting at a certain, it has some intercept on the y-axis. This shows that there is induced period. The period between starting zero time to some time after which reaction is going on, this is induced period. ठीक है, and there is inflection point, rate increases after this, and there is again it goes to stationary, and at that point if we put or form a क्या कहते हैं tangent, then we get the inflection point of the curve. On propagation, on integration, 1 upon A plus B is changed into ln B plus X minus ln AX is equal to Kt plus C. This I have told earlier. This is reaction number 3. In order to get value of C, we can get C when X is equal to 0 and when T is equal to 0. When T is equal to 0, then Kt becomes 0. And when X is equal to 0, all these things, X, ln A minus X, B minus X, these are whole convert to some other factor. So C comes out to be 1 upon A plus B ln B upon A. ठीक है, now put the value in equation 3. अब हम इसकी वैल्यू इक्वेशन 3 में पुट कर दें C की, then we have equation 1 upon A plus B in bracket ln B plus X minus ln A minus X bracket closed. This is equal to Kt plus C. C क्या है? 1 upon A plus B. Kt is as it is plus 1 upon A plus B ln B upon A. From this we calculate K, and K comes out to be 1 upon A plus B into T ln A upon B into B plus X upon multiplied by A minus X. This has been experimentally verified equation. So we can say induced reactions, the autocatalyzed reactions are induced reactions. They require some induction period and they have some type of temperature rise or activation energy which is to be reached before they can perform the reaction completely. Thank you students. Next we will oscillatory reaction we will study in next lecture. Thank you so much.